Hi everyone, welcome to our second session. Titiksha will be taking the session and she'll be going through the basics of Flutter. We did cover a few things last time, but we'll be doing that again because there was some problem in the last session. So Titiksha, you can start now.
Hello everyone, I'm Diksha Sharma, Project Coordinator for Flutter, and today I'll go through the basics of Flutter. So, basically, Flutter is a cross platform app. It's used for making create cross platform apps like mobile, web, etc., and integrates them with a single programming language. The language used is Dart that we have done in our previous session. I think we're familiar with it now. And yes, it was developed by Google, but it is open source to all external contributors. So basically, the syntax of Dart supports most of the object-oriented concepts and is used to create Flutter applications. Everything in Flutter is a widget. So the central idea for widget is that you build your UI out of widget and they describe what the view should look like and the current configuration and state. So we'll go through this topic in more detail in the upcoming sessions as well. Before start with the code, uh, I'll go through the structure of a project. So when we create a Flutter application, these are the files and the folders that are created. So the first one is .idea. The .idea folder contains the IDE's project related settings. Like they are mainly the XML format file, and we have to know not make any manual change here. Then we have the Android folder and the iOS folder. So the Android one for the Android specific settings, the resources and code, and similarly there's one for iOS. So all the platform specific changes are made in these folders. Then we have the build folder. The build folder contains the output generated when you build or run a Flutter project. The release related files and folders like the APK, app bundles can be found in the build folder. Then we have the library folder. This holds the Dart code that is used to run the application. The main file, that is the main.dart, is also stored here. And like in all other programming languages, the execution and the compilation starts from the main file. So it exists in this folder. Then we have the test folder. So the test folder contains, like, it lists all the code, and you can write test and the test cases here to like check your application and it's working. Then we have the get ignore file. So there's a get specific file, and it tells which files or folders are to be like ignored in the project. Then we have the .metadata file. So this contains all the Flutter related metadata as the name suggests itself. Then we moving further, we have the .packages. Like I like to specify here that the .metadata, .packages, and the like .pubspec.log, all these are created by Flutter itself. So like they are used by the framework internal uses, and we actually have to make no manual changes in these files. We normally don't touch these files. So in the packages file, the project code is composed of numerous libraries and packages. It holds the path to each of the libraries and packages, and like some packages are pre-installed while some are downloaded during the development of a project. Then we have the expense manager.iml. So again, like we have to make no changes in this file, and Android specific files that contain info about the Java module are in this one. Then we have the spec.yaml file, and in this is a Flutter specific metadata and configurations file. So we configure all the dependencies that are required, such as all the external packages that we include in our program. They are like we have to specify them here, and like the image, assets, font files, or the application version, everything is included in the pubspec.yml. Also, like I'll explain this in the next slide as well. Like when we specify all the changes in like in this file, a pubspec.log file is created in the program itself, and it's a helper file that no, we have to make no changes in the pubspec.log file, and it lists the specific version of each dependency that are stated in the pubspec.yml file. So like it ensures, okay, when we specify the dependencies in the pubspec.yml file, a helper file gets created next to it, that is pubspec.log file. We have to make no changes in this log file, and it lists the specific version of each dependency and ensures that it stays same across the machine. Then we have the readme.mp file, that is like that is a markdown file that is primarily used to describe the project in a Git repo. So exploring a bit more about the pub package manager. So it manages the Dart packages that are inside a Flutter project, and pubspec.yml file imports the Dart dependencies. So we use the command flutter packages get to install all the packages and the dependencies that we need in our application. And as I said in the previous slide, a log file gets created, that is pubspec.log. Okay, so we are, I'll explain this concept via an example. So to create a new file, to create a new application, we go to the file option. Then we select new, and new Flutter project. We select the Flutter application option, and we name a Flutter app. And when we create finish, we get a screen like this. So here we see a default Flutter application that is created when we start a project. And as I had explained in the previous slides, these are all the files that get created. Okay, so this is the pubspec.yml file that lists all the dependencies that are required. If we want to add new dependencies, we just add it here itself. And main.dart file is where the compilation starts. We have a main function here as well. And like all other programming languages, the compilation and execution starts from this function. Okay, so I'll just compile and run this program once to see what it does. And this is our app that is created. So we have a button here, and when we press that button, the value increments by one. Now we'll make some changes in this application. Like I'll change the text here. And then there's this feature in Flutter that is called Flutter Hot Reload. Now, when we select this option, we don't have to build the whole application again. Rather, it just starts starts from the state we left it in it. So we'll compile it again, and I'll explain this concept again in a while. While this app builds up, we'll just go through the slides of this topic as well along with it. So what we are doing now is a hot reload. So there are like three types of ways to build an app. So first is hot reload. That is, we load the code directly. We load the code seamless into the virtual machine, and it reveals a widget tree, preserving the app state. That is like the main function or the init state function that is not rerun. The init state function is basically how the app should be in its initial stage. So we don't have to run that function again. Rather, it starts from the previous state that we left it in. Then we have the hot restart. That is, it loads the code changes into the virtual machine and restarts the Flutter app. In this way, we lose the app state, like it's from the initial state. Then we have the full restart. That is, it restarts the app, and this takes longer because we recompile all the files and all the codes in it. On the web, it also restarts the Dart development compiler. So I like to state here that the hot reload feature is not yet in the Flutter uh, web app web apps, but it is present in the mobile app. Then, as we have talked about widgets earlier, like everything is Flutter is composed of widgets. So these widgets are immutable, and hence they make the UI lightweight. There are basically two types of widget. One is stateless and the other is stateful. The stateless widgets depend only upon their own configuration, that, like the static image in an image view. So we specify all the things in the code itself that how the widget should look, and it doesn't depend on the dynamic properties, while the stateful widget maintain the dynamic info and do by interacting with the state object. So stateful widgets change according to how the state changes and what the user does in our application, and we keep on updating the state object according to it. Both stateless and stateful widgets we draw in Flutter. So the basic difference that we can say is the configuration to the state object. So we'll see the code again, and Okay, so here we see that we see a stateless widget and a stateful widget as well. So in the stateless widget, all the things are already specified, like how what should the title be, or and like, how the home page should look like. But in the stateful widget, we see that we keep on increasing the value according to the dynamic properties. Like when we tap that button, the function increment counter gets called, and in that function we see that we are changing the state. The value of counter is increased. So it is a stateful widget that totally depends on the configuration of state at that time. So let's go through this concept more clearly by building an application. So as we dive into any programming language with the Hello World, let's create a Hello World application in Flutter. We'll write a program from scratch. First, we import the package. Material.dart. So material.dart contains all the widgets implementing the material design. Material design is a design language developed by Google that is used to build the digital experiences for Android, iOS, Flutter, and web. So it like includes the display, navigation, input, communication, and all the predefined icons that might be required in an application. Also, while using this, we check if in the dependencies we have stated that material design value is true in the public.yml file. Then we create the main function from where the compilation of this application will start. And as we have studied Dart, uh, making this arrow is a shorthand way of writing a function that includes only one line of code. My app is the name of the application is the name of the class that I am about to design. And we are writing here extend stateless widget because in this program we'll already specify how the widget should look like, and it would not depend upon the state. So we specify it here itself. Okay, so the build method for the widget is basically how to display the widget in terms of other low-level widgets. So we'll include other widget inside this that will specify how our application should look like. We use override here to specify that the class should override over the superclass. Then we write return material app. Since we're using material for a UI, then we'll specify the title for our project. So scaffold is a widget that is inside the material library, and it contains some like predefined stuff like the app bar. You can just specify the app bar here, and inside the app bar we'll write the title that and the text that should be displayed on it. Then we'll specify what we want to display on the body of our application. And since I want the alignment to be in the center, I'll specify it here. When I type the text, hello world, and now we'll build our application. This is how our application would be displayed, and we have our program ready. And we have our hello world application ready as we see on the screen.
Titisha, can you go back to the code? Yeah, thanks. So today we learned how to make a very basic app, the Hello World app. So as you can see, the first thing that we do is to import the material package, which is provided, like which has been provided by Flutter team, and we don't have to write the code of each widget from scratch. We can get that easily by like using this package. So then we write the main function, and then we make our class. The name of the class here is my app, which extends the stateless widget. So as you can see, it's basically there's nothing dynamic in our code. So we are using stateless widget, and they're basically used for designing the UI. And for the dynamic part and for part where we are doing some changes on screen, then we use stateful widgets, which we'll be exploring later. Then we write at the rate override. So what we are doing is we are actually overriding the function build function. So we are telling our code that we are overriding this function by writing this override. And this build function has is like the function from this stateless widget class, and we are using it, we are overriding it, and this will return a material app widget which has like title and home, and then home has a scaffold which is also a widget, and then it has bunch of widgets under like it. So this forms a widget tree, and there will be many more widgets that we'll be exploring in upcoming sessions. So I'll quickly share my screen and show you the app that you have to make this week. Uh, this is the app that you have to make, and this is a very simple app. It has a circle avatar here. As you can see, this is a circle avatar which has my image. Uh, you will learn how to include your images. uh, we already went through like assets that we have to include in our pubspec.yaml file, so I'll be sharing more resources on that, like how to do all these things. So as you can see, this is our column widget, which has some widgets inside it, like it has a circle avatar, and then it has a text, and then there's a row which has some icons. So this row is also a part of like this column contains it, so it's they're arranged in a column. So this is what you have to make this week. I'll be sharing some resources where you can just you can go through that, and you can also reach out to your project coordinators if you face any difficulties. I'll also be making a walkthrough video along with the code, and I'll be sharing that with you all by Friday. So the deadline for the task is Friday, and if you're stuck somewhere, then you can reach out to project coordinators, and I'll be sharing the walkthrough video as well, so you can go through that. So yeah, that was all for today's session.